Hello students, and welcome back to another algebra video, same as usual. Pause the video, try that problem in your notes, and then unpause it to do it with me. Okay, we are subtracting two polynomials. I can tell because there's parentheses around a polynomial. It says minus, and there's parentheses around another polynomial. So, we are subtracting two polynomials. Let's write them in standard form first, shall we? So here, I notice we have degree 4, degree 2, degree 1. Hey, 4, 2, 1, that sounds good. Now over here, or that's already in standard form is what I mean. So we are good there. Now here we have degree 0, degree 2, and degree 1. That's not in standard form. This should be going 2, 1, 0. So let's rewrite this. We have minus 9t squared minus 7t plus 12. Okay, and that is 8t. Alright, so now, notice how we have 2, 1, 0, and 4, 2, 1. So when we write our our subtraction problem, when we write t to the fourth minus t squared plus t, we also need to put a plus 0 on the end. We want 4, 2, 1, 0, so that we have enough spaces for all of these, 4, 2, 1, but we also include the 0 of the other polynomial. Okay, so that's our first one. Now, we're going to put our second polynomial right underneath it, and we will have minus t squared minus 7t plus 12. And notice how we left space. There are 0 t to the fourths in our second polynomial. Remember, you can write 0t to the fourth if that helps you. If you're like, no, that's confusing, get rid of it. It's whatever helps you. Okay, and now remember that when we subtract these, all of the signs change. So negatives become positive, positives become negative. All right, and now we just have to add t, and remember this is like 1 t to the fourth, minus 0 is just t to the fourth, negative 1 t squared plus 9 is 8 t squared, positive 1 t plus 7 is 8t, and 0 minus 12 is negative 12. And there you have it. We already had all of our t to the fourths together, our t squareds together, our normal t's, and our numbers. So that made it nice and easy to subtract them all together. Okay, that's what we did in the last video. What do we have for today? Today, we start our work on 7.2. There will be another video on 7.2, so this is the first half of 7.2. It is all about multiplying polynomials. We added and subtracted them, but now we're going to multiply polynomials. So that's the learning target, is to know how to multiply polynomials. The success criteria is that you can use FOIL, F-O-I-L, to multiply polynomials. Now I know you might be thinking, foil? What, like aluminum foil? Like in my kitchen? No, not aluminum foil. FOIL is a method to multiply polynomials, which we are going to learn right now. FOIL is an acronym. It stands for something. So here you see FOIL stands for first, outside, inside, last, or first, outer, inner, last. And you'll see they did a beautiful job of color coding it. When they say first, they mean the first terms in our binomials. So today is all about multiplying binomials. So see here, x plus 1, that's 2 terms. X plus 2, that's 2 terms. So these are 2 binomials we are multiplying together. And first, oh goodness, they forgot their parentheses over here. That's confusing for me anyhow. Okay, there we go. Now it'll stop being confusing. When they say first, they mean the first out of each set of parentheses. So here the x is first, and here the x is first. When they say outer, they mean the ones on the outer ends of all the parentheses. So this x and this 2. When they say inside, they're talking about the two terms right together on the inside of the parentheses. And when they say last, they're talking about the two last terms in each of the binomials. So the 1 is last in this binomial, and the 2 is last in this binomial. So what you do is you multiply the firsts together, you multiply the outers together, the inners together, and the last terms together, and then you add all of them up, and you get your answer. So, let's see an example. We have 2 examples, and then I'm going to give you some time to try it on your own. So, multiplying binomials using FOIL. I am a big color coder. You might have noticed this by now. But we are going to do our FOIL acronym, and we're going to color code it. So, FOIL right here. So when we say first, remember F is first, I'm taking the X and the X. So X times X. Remember this from last chapter when I'm multiplying 2 variables with the same base, I add their exponents. So X times X is X squared. Beautiful. So I did the first, done with that. Now I'm going to look at the outer terms, or the outside terms. That is X and negative 6. So X times negative 6 is negative 6x. Just put them together like that. And we're done with the outer terms. Next, we're going to look at the inside terms. Those are the 2 right next to the parentheses. So that is negative 3 and x, negative 3 times x, which is negative 3x. And last, but not least, we have our last terms, which are negative 3 and negative 6. So negative 3 times negative 6 is positive 18. Now we're not quite done yet, because when we multiply 2 polynomials together, we will always get a polynomial. That's right, polynomials are closed under multiplication. So these by themselves are not our answer. The answer is when we add all of these together. So we have x squared minus 6x minus 3x plus 18. But wait a minute, look at this, I have an apple and an apple. I can combine like terms. So instead of just writing it this way, I'm going to put the minus 6x and the minus 3x together. And this is x squared minus 9x plus 18. And there you go. That is your final answer for multiplying these 2 binomials together. So this is equal to x squared minus 9x plus 18. Woohoo! Okay, that was my Tigger impression for any Winnie the Pooh fans out there. Okay, now, if you're like, cool, great, got it, first outside, then inside, last, FOIL, got it, cool, pause the video, try B on your own. But if you still need some help, that's okay. Do it with me. Just keep the video rolling. So I am still going to write out my FOIL acronym, and if you have colors, I recommend doing the same. All right. First terms are 2x and 3x. So I have 2x times 3x. 2 times 3 is 6, and x times x is x squared. So 2x times 3x is 6x squared. Next, I'm going to look at my outer terms, and that is 2x and negative 5. So 2x times negative 5. 2 times negative 5 is negative 10 times x. So negative 10x. Wonderful. Our inside terms are 1 and 3x. So we have 1 times 3x. Anything times 1 is itself, so this is just 3x. And now let's take a look at our last terms. 1 times negative 5 is negative 5. Now, let's add them all together. We have 6x squared minus 10x plus 3x minus 5. Remember that we can combine our like terms. You can do this in this step, or you can do it in this step. Doesn't matter, I don't mind. And we are left with 6x squared. Negative 10 plus 3 is negative 7x minus 5. And there you go. 6x squared minus 7x minus 5. Let's check and make sure that we were right. X squared minus 9 plus 18. And 6x squared minus 7x minus 5. Booyah. Okay, so now I want you to try. Multiplying binomials together, foiling binomials, is very critical to algebra. You're going to use this in advanced algebra. You're going to use this later on in this class in Algebra 1. So I really want to make sure you understand this. Try the examples above, pause the video and try these, and then unpause them to do them with me. So I am going to do my FOIL acronym. Oops. Okay, and we're gonna go first. M times m is m squared. Outside, m times negative 7. M times negative 7 is negative 7m, because remember we always write the number first. Whoops, green, give me green. Inside is negative 3 times m, which is negative 3m. And last, our last terms are negative 3 and negative 7. Negative 3 times negative 7 is positive 21. Now, we're going to add them all together. M squared minus 7m minus 3m plus 21. Don't forget to combine your like terms. Negative 7 minus 3 is negative 10. So we have m squared minus 10m plus 21. And there you go. All right, for the next example, what if you're like, Miss Dodge, I am so bored of writing out the word FOIL every time. I don't want to. Okay, I'm going to show you a different way to think about it now. Now, we're going to go back to our distribution rainbows from our distributive property. First, I'm going to draw a rainbow for the first terms. X times x is x squared. Next, outside, I'm going to draw a rainbow to those two terms. X times 2 is 2x. Next, inside, negative 4 times x is negative 4x. And last, negative 4 times 2, which is negative 8. So you see how this pattern of rainbows, it goes, we start with x, and we go to the first one, and then we go to the second one. And then we go to negative 4, and we start with the first one, and we go to the second one. So that's another way you can think about it, is I just take the x and I multiply it by the first term in the binomial and the second term in the binomial. And then I do the same thing with the -4. I go to the first term and then the second term. But it's the exact same thing as foiling. First, outside, inside, last. If that's easier to you than writing out all of this, go for it. I don't mind which one you use. But remember, we're not quite done here because we still need to combine our like terms. So we have x squared, positive 2 minus 4 is negative 2x minus 8. And the more you practice foiling things, or multiplying binomials together, you'll soon be able to do this step in your head. I can just look at a binomial like this, and I can say x squared minus 2 minus 8, or minus 2x minus 8. The more you practice it, the more second nature it becomes. So I encourage you to keep practicing. Okay, so that is the FOIL method. At this point, I want to tell you about 2 other ways that you can multiply binomials. They are going to be in video cards up on the screen because I didn't want to put them in this video. I think personally that foiling is the easiest, most straightforward way. You can also solve using the distributive property, or you can solve by using a table. So both of those videos are up here. And if you're like, foiling doesn't make any sense, try out one of these 2 videos and see if that works better for you. But if you like foiling, forget about those videos up there, don't worry about it. Okay, that is the end of that plug for the other videos. So, if you have questions, try rewatching this video, try watching some of the other videos. If you're like, foiling, I just don't understand FOIL, try using the table, try the distributive property. Ask your teacher, ask a friend, whatever works for you. But make sure that you get your questions in. All right, here are some practice problems that you can try. I know there's not that many of them. These ones are using the FOIL method. The other problems in the ebook were using the distributive property or the table, so I saved those for the other videos that were in the cards back there. All right, and of course, we will end our video with a launch. So, this one comes from Sophia Loren, and it says, "Beauty is how you feel inside. It reflects in your eyes. It is not something physical." This really speaks to me because I remember being in high school. I remember how insecure, like, thinking about beauty is, and this goes for men as well. When we say beauty, we're not just talking about pretty women, we're also talking about handsome men. So when you talk about, like, what a handsome man looks like, or what a beautiful woman looks like, right? Society has these things that men and women need to have in order to be beautiful. Women need to be very thin, long legs or something like that. Men need to have rock hard 6-pack abs, right? No, they don't. You don't need those things to be beautiful. Beauty is how you feel inside. If you feel beautiful, you like the body you have, you are beautiful. Even if you don't like the body you have, you are still beautiful. Beauty is how you feel inside. So instead of focusing on looking beautiful on the outside, focus on how you feel inside. Because how you feel inside is going to change the way you think about how beautiful you are. It reflects in your eyes. In some of the summer camps I went to, I don't know if any summer camps you've been to do it this way, but girls weren't allowed to wear, like, short shorts or like tank tops or anything like that. And they told us, don't dress so that boys will, or girls or whatever, will look at your body. Dress so that they'll look at your eyes. They say that the eyes are the window to the soul. So when things reflect in your eyes, when you have people look at your eyes, you're going to make a much more meaningful connection than if you're just trying to get them to look at the rest of you. So beauty is not something physical. Beauty is this construct, this social construct that society has said, this is what makes a girl beautiful. This is what makes a guy handsome. And society's wrong about a lot of things. Society has been wrong about a lot of things. Look at the way that racism is still a thing. Society can be very, very, very wrong. And their standards of beauty are also very, very wrong. I'm not particularly beautiful in the societal terms of sense. Doesn't mean I ain't beautiful, though. Like, you are beautiful. All you men are handsome. Beauty is how you feel on the inside. It's not something physical about you. It's not how long your legs are. It's not how rock hard your abs are. It is how you feel on the inside. So focus on how you feel on the inside instead of on how you look on the outside. That is my launch for you today. Take it with you as you go throughout your day and all of the days that you go through. Thanks for being here. Thanks for watching. Bye.